Right. Good morning and welcome to week 5 of site planning. And this week, like the previous weeks, we'll continue on down the down the line to we'll continue on down the line of the site planning and design process sequence. And over the last few weeks, we've discussed programming and site selection, and we've spent some time extensively discussing site inventory, both site inventory of and the inventory of physical, biological, and cultural attributes of a site. This week we'll try and put them all together and put them through the process of site analysis. Now, what's interesting is that when you're conducting a site analysis, this is arguably the most important step of the site planning and design process, and it's up to this point, it's still not a linear process. In other words, when you're conducting a site analysis, there is a possibility that you will need to come back to the site inventory process just in case you've missed something out. I know over the last couple of weeks I have said that site inventory is not about getting all the data. It's not about how complete your data is. The most important aspect, the most important thing is that how you interpret the data that you collected in the site analysis process. However, ideally you can build a complete picture or a complete data set during the site inventory process, so that you won't have to keep coming back to site inventory during the site analysis. So, although it's not about how complete your inventory is, it's more about how you interpret the data that you have. But a complete data set would be ideal. It is desirable to minimize the possibility, or to reduce the possibility of you looping back from site analysis to inventory and so on. So here are a few points of discussion that I'll highlight today. There are at least 4 aspects to site analysis. There are on-site influences, there are off-site influences, and then land use suitability analysis, whether it's single attribute or multiple attribute analysis, and finally, what to consider, and finally, other aspects to consider when assessing site suitability. Now, the idea of the site inventory and site analysis, the idea of the site inventory and site analysis processes is to provide a context-sensitive site planning. There are 3 basic purposes that you are trying to serve or trying to fulfill when you're conducting site planning. First is the first purpose of site planning is to describe a site, and that that purpose is expressed through the site inventory process. And when you're trying to provide a context, or when you're trying to conduct a context sensitive planning, whether it's site planning or spatial planning in general, here are some probing or probative questions that you can ask um, when you're conducting each stage. So for the purpose of describing a site, the activity is site inventory, and you can ask yourself the main question to ask yourself, or to ask your team when you're conducting this stage, is what is the ecological structure and function of the study area? And then you will have some sub questions like how the sun and prevailing winds move across the site, and are there any significant trees or plant communities on the site, and what are the site's stormwater drainage patterns like, or where do the site's stormwater drain run, and so on. These are just 3 examples. You may end up with more than 3 questions, 3 sub questions, and then following the description, there is a diagnosis. And this is where we are at the moment, site analysis. And the diagnostic stage is simply to find out the opportunities and constraints for implementing the project program. And the project program can be previously determined. Or I want to build a theme park, I want to build a resort, etc. And then you find out the requirements of the theme park, the requirements of the resort, etc. That's what it's meant by programming. But for the purpose of this unit, the programming, I'll put the programming together in the conceptual design stage. Programming can also come as a result of site inventory and site analysis. So you describe the site first. How does it look like physically? What's in there? What's in there biologically? Are there any constraints from the cultural aspects? And then you find out where the opportunities and constraints are, or what the opportunities and constraints are. Are there any potential site access points? Can we orient new buildings to maximize solar collection? Are there steep slopes that require stabilization, or are there steep slopes that should be left alone? And then you come up with a program there. Okay, so with this in mind, with the site inventory and the site analysis results in mind, we can create a suitable program. What is the site suitable for? Maybe you don't have anything in mind, but judging from the characteristics, then you can sort of determine whether it's suitable for a theme park or a chicken farm. Finally, once you're finished with the diagnosis, like a doctor or a medical professional, you come up with a prescription. And that is the conceptual design. The most important question to ask when you're prescribing the design is, how can the new development make a positive contribution to the community? Are there any natural or cultural site features that can be protected and or restored? And can the site's development maximize good views to off-site amenities? Or another example question for you to ask yourself and the team is how can we maximize the natural features of the site so that we don't have to um, modify it extensively. As a continuation, to that to that table, and to sort of lead into our discussion this week. Um, as we all know, a site inventory consists of putting together or listing, describing the physical, biological, and cultural attributes of a site, and that will give us a holistic, hopefully, will give us a holistic picture of the existing site and the contextual conditions. And I need to remind you again that during the site inventory process, ideally you don't only consider what's in the site, you also consider the physical, biological, and cultural attributes of those of the surroundings. Um, ideally there should be like a buffer area or so, but I think a buffer as in okay, we need to consider our surroundings as well, but how far into our surroundings do we need to consider? That really depends on what you're going to put on your site. Some functions may require a further and a more extensive understanding of the surrounding context. Others may not. So, for example, if you're building a real estate or a cluster of houses in residential development, you may not need as much. You may not need to consider. You may not need to consider the surrounding environment to such extent as if you're building a theme park or an industrial estate, for example. And a site analysis itself consists of two main components. The program itself. What are you going to build? What are your goals and objectives? What sort of land uses and activities that you're going to introduce? And um, if there are any, what are the phases in which you will introduce your the new land uses and the new activities? Because sometimes you can't build everything all at once. When you're introducing new functions, you may need to introduce them in stages. So stage one, maybe stage one in an industrial development, you will build one area, and then you will continue to sprawl as the development progresses. Or maybe when you're building a residential cluster, then you might construct certain clusters at first, different clusters at first, and then putting them all together, and so on. So the program is one component, and then the, of course, existing condition, which consists of physical, biological, and cultural attributes. From these two, matching these two components together, adding these two components together, will give you an idea of what is suitable and what is not, or the constraints and opportunities. So that's site analysis in a nutshell. Let's go further. Let's go explore constraints and opportunities a bit further. For example, I think I've used this illustration before, but this is just to serve as a reminder of what the constraints, of what possible constraints and opportunities are. You may have, by this point, at this point, you may have a site in mind, or you may have found a potential site for your assignment, for your group assignment. And let's just say that this is the site that you found. This is the developable area, or the potentially developable area. As you progress through your site inventory process and you may conduct site analysis as you go through the inventory process, so that you don't have to conduct those two separately and sequentially. You might say, I'll have a look at the biological attributes first and map things out and see how suitable the site is for development according to those attributes. And then I'll continue to add the other attributes as we go along. And as you conduct your site inventory and site analysis, you may sort of feel that the ground underneath your feet, or the ground beneath your feet, is shrinking. Could be, but most of the times it's like this. So you have your developable area, and as you conduct your site inventory and site analysis, you may discover a cluster, or you may discover ecological communities. In this diagram, it's a specimen tree or a cluster of vegetation that you need to preserve, or you need to protect. That means you have now your developable area. As I mentioned, the ground is sinking beneath your feet. You have less developable area because of that. And then as you progress, you may find, as you progress in inventory and analysis, you conduct a hydrology analysis, and you discover that there's a stream and riparian zone that you must leave alone. That you try not to modify as best as you can, because that is a crucial drain. It's a crucial drainage stream. If you decide to block that off in some ways, or reroute it in some ways, then it might cause problems down. It may cause problems down the line. And so once again, the ground beneath your feet shrinks. And finally, this is just considering the attributes and the aspects within your site. And then when you consider the same attributes that are located outside your site or in the surrounding area, you may find an off-site landmark, such as a potentially picturesque or potentially good vista or a view from your site. Therefore, you may decide that, okay, we'll need to, let's just say that this is the highest point of the site. You may decide that because there's a landmark there, there's a potentially good view there. Let's make a way. Let's make a way for this area to be a viewing platform of some sort, and ensure that there's good, clear visibility in that direction, so that people visiting your site, or the people using your site, may have unobstructed view of the landmark outside. Okay. Let's now talk about on-site on-site influences, or the internal attributes of a site. when you're conducting when you're conducting a site inventory, you're basically listing and mapping the site's existing conditions. However, site analysis goes well beyond mapping the existing or the site's existing conditions. The site analysis, as I mentioned, as I demonstrated in the previous table of description, diagnosis, um, and prescription, the site analysis is indeed a diagnostic process that identifies opportunities and constraints for specific land uses. And site inventory provides the physical, biological, and cultural data for this program-driven analysis. As you progress, you may find, as I previously demonstrated, that some locations on the site may be unsuitable for development because of intrinsic physiographic constraints or other or perhaps other constraints. And these constraints physiographically may include steep slopes, shallow bedrock, surface waters, or wetlands. Other parts of the site may be suitable for development, but but because they're relatively inaccessible, then you may decide not to develop the site, not to develop that part of the site at all. So lack of access may be due to intervening site constraints. For example, if you find that this is a developable area, this is a green site for development, oh, that's awesome. You'll get a great view from up there and everything. However, from the access point all the way to the highest point of the site, you have accessibility constraints. To get up there is quite steep, and because it's so steep, the ground may be unstable if I decide to modify the slope. If I decide to cut it, and if I decide to cut the slope and fill the slope and modify its elevation in some way, or modify its angle in some ways, it's going to become unstable. What if I build a ramp or a staircase or anything that can help people access the high point? But then you find out that it's too expensive. It's too expensive to introduce a new construction because of the physiological constraints. So therefore, well, it's a developable area, but it's inaccessible. So let's just leave it alone. So because of those many things, consequently, pockets of undevelopable land can render the original development program unfeasible because of the prohibitive costs and prohibitive costs of construction or extending roads, and perhaps it is possible to extend the roads, it is possible to extend the pathways, it's possible to construct. However, it's not possible for you to extend the utilities or the infrastructure or other infrastructure to isolated areas of the site. So there are many things. There are many things that can render a spot or a site unfeasible for development. So you need to gain as much understanding as you can for the purpose of the site's development. And you need to gather as much understanding as you can of the site's development limitations. And when you understand these limitations, not so much the not just the opportunities, but when you understand these constraints better, when you can, then you understand, then you may have reason to revisit and perhaps even revise the project's program if you already have a program in mind. I want to build an industrial estate, but because of the site's constraints, you may need to remove some objectives. And if it's an extreme, if the constraints are extreme, then you may need to actually revise what you're doing. It's not suitable for industrial development. Then either you move your development to a different site, or you do something else. I want that site, but I can't. But I can't build an industrial estate there. So I'll just build a residential cluster there instead, or I'll just build a resort there instead. But most of the times, I have this program, and I have people paying me to develop this program. So the program is not negotiable, as in I can't just change the program to something else. I'll just have to find a different site instead. Now, design influences also include existing on-site features that are retained undisturbed in the site plan. A steep wooded slope, for example, is a natural feature that can contribute to the site's unique sense of place. Other natural features can be viewed as development constraints that, if you develop these natural features, it would have a detrimental environmental or community impacts. However, these features also create opportunities to create or to integrate green space or green infrastructure into your site plan. There may be ecological linkages, and ecological linkages between your site and the surrounding landscape can be strengthened by protecting and even restoring green infrastructure. And these multifunctional green spaces not only have significant ecological value, but they can also provide recreational and educational opportunities. Even if you decide not to use it for educational or recreational purposes, the ecological spaces, these ecological features, can add aesthetic amenity and thus enhancing your property values. And a landscape's green or ecological infrastructure, it could be open water, it could be wetlands, it could be aquifer recharge areas, some sort of steep hill or steep topography, and other unique landforms. These environmental resources, they typically comprise of a network of patches of and corridors, and they do warrant your protection. So, moreover, this green infrastructure, which provides a wide range of ecological services, can also serve as a spatial framework for shaping future growth and subsequently future redevelopment. Now, building in difficult locations require more time, more money before, during, and after construction. Steep slopes, for example, are a significant constraint for many developed uses. Building foundations constructed on steep slopes are generally more complex, stepping down a hillside, and therefore are more expensive to design and build. And in locations where site drainage is poor or where subsoil is unstable, additional effort is needed to ensure the building's structural integrity. And building on difficult sites also increase the risks of development impacts, both on and off site. And acquiring development permits for difficult sites may be complicated. So therefore, by the potential impacts of construction process as well as post-construction uses of the site. Environmental impacts of building in difficult sites can include soil erosion. It can also include groundwater contamination and degradation of critical wildlife habitat, and consequently, sites with significant physiographic constraints may be economically and perhaps even politically unfeasible to develop. In this table, there are common development constraints. The constraint may be because of an ecological infrastructure or ecological or green features, so aquifer recharge areas, wetlands, and so on. It could be due to health or safety hazards. You may have potential floodplains or flood areas in your site. Your site may be situated on or near an earthquake fault zone. If it is, then then I would suggest to leave it alone and go find a different site. And other areas susceptible to landslides, maybe because of the very steep topographical feature or properties. There are other physiographic or physiologic barriers. There may be natural resource constraints. It could be a prime farmland. It's just too much sand and gravel in the area that you can't really do anything about that. It may be a protected area, or it could be a protected area because of tree specimens or wildlife habitat, or it could be a protected area because of scenic views. There could be historic constraints or cultural constraints, like heritage and legal restrictions, and there could be constraints of other nuisances such as noise, undesirable odors, or unsightly views. This is not an extensive list of development constraints. There could be other constraints. There could be other constraints. Could be other constraints added to this list as you conduct the site inventory and analysis of your site. There could be the list is this is a very flexible list. It really depends on the uniqueness of each site. Another development constraint that has something to do with health or safety hazards would be, of course, natural hazards. And if you ignore these potential site hazards, it can lead to very expensive and even deadly and potentially deadly disasters. Earthquakes, hurricanes, and other natural hazards, they usually occur at infrequent intervals. Sometimes these intervals or these occurrences can be anticipated. There are parts of the world that are very hurricane prone, or they do experience hurricane seasons. Um, I think the north, south, east, west. I think the eastern coast, or sorry, maybe the western, the west coast of the United States. The west coast of the United States experience a lot of hurricanes and tropical and not tropical, yeah, hurricanes and tropical cyclones. Um, California, or was it? Yeah, I think California experiences wildfires regularly as well. So some of those natural hazards occur at a certain interval, and you can anticipate and plan for that. Parts of Australia go up in flames every now and then, bushfires, wildfires. I think we also have a similar we have a similar tendency here as well. I think over the last couple of days, people have been talking about a tropical cyclone, um, Seroja that passed through the eastern part of Indonesia, and other than that, we also have tsunami and earthquake potentials. Anyways, um, if these natural hazards do recur, then the recurring nature of these events suggests, um, however, that's not a question of if, but when. So if it occurs frequently, then you should ask yourself when it occurs um, in areas at risk. Earthquakes is a dangerous geological hazard, imposing shaking forces on buildings, bridges, utility lines, and other structures. And yes, the risk of an earthquake can be mitigated through innovative design, through innovative construction methods or construction techniques. However, if you can reduce, however, I think you can reduce the risk of earthquake damage significantly um, by avoiding development in earthquake prone areas. So I think in general, for natural hazards, if the risk can be significantly reduced by not building in the most either seismically active areas or other risky areas, then clearly if you can avoid development, then clearly it is a prudent course. It is a prudent course of action. It's better to do so. However, you you can still develop in natural hazard prone areas by introducing innovative structural intervention constructions, or you can conduct or you can carry out land readjustment programs, for example. So, well, natural hazards that may impact your site are usually weather related, and during periods of good weather, the dangers may be absent, but the danger is greatest when relatively infrequent but severe weather events do occur. Hurricanes, for example, weather events with significant land use planning implications. And hurricanes generally develop over water, so the risk they pose is greater in coastal communities. And because hurricanes are long-lasting storms, their persistent rain can saturate soils, and they can also exacerbate the threat of local flooding. As I mentioned, there have been significant advances in construction methods, and these advances have reduced the risk of structural failures from earthquakes and from storm wind loads. But when we talk about hurricanes, and a hurricane's main threat to life and property is storm surge flooding. And storm surges associated with hurricanes, they create a wall, or they create walls of seawater that are several meters above normal high tide elevations. So development in low-lying areas is especially vulnerable to the devastating social and economic impacts of coastal flooding. And during severe weathers, the mean sea level, or the average sea level, can slowly rise and continue to rise up to several meters over the next decade or even the next century, as you know, I think natural hazards, especially the climate-related natural hazards like severe weather, we should take extra consideration into that, because as we know, climate change is a very real threat, and so over the following decade or century, then sea levels may continue to rise, and other severe weather events may also affect the frequency and severity of other of these weather events can also affect the way we plan sites. And when we talk about flooding, flooding is exacerbated in watersheds where building rooftops, streets, and parking lots and other impervious land cover substantially reduce the capacity of the landscape to retain and infiltrate storm water. The overall managing the risks associated with climate change may sadly include discouraging development and redevelopment in higher risk areas. It also includes the increasing the capacity of upland areas to infiltrate maybe stormwater runoff. So in this case, if you find out that your site is natural hazard prone, maybe the best step to take would be to avoid development. But if you can't avoid development, then the second best option would be to introduce structural interventions. Or if you can't avoid development, then you can discourage development, or you can reduce the development intensity of that area. Now, other than on-site influences, there are off-site influences, off-site cultural and biophysical features. Can also influence the way you organize the site, so the organization of your site and the design of the new buildings that you will introduce to the landscape. And the number and location of entrances to the site, for example, are determined in part by the transportation infrastructure just outside of the site's boundaries. Oftentimes you have no choice but to situate the main access to your site adjacent to the main road, rather than constructing a new road to go around the site or to go behind the site, for example. Adjoining streets and perhaps nearby transit stops may suggest preferred locations for new site and building entrances. Um, Corner sites at the intersection of major transport infrastructure or major streets, for example, may warrant a special design treatment. And a new building's primary entrance may be located at a corner, and the building facade that faces the intersection may be rounded to sort of turn the corner. Other offsite influences would include land use regulations. Um, land use regulations may limit, or other regulations may limit the number of vehicle entrances to a site. They may impose a minimum distance between vehicle entrances and minimum distance from nearby street intersections. They may also regulate the placement of new buildings in relation to property lines and public right of way. Other than that, views or vistas to prominent offsite topographic features, trees, or water bodies also warrant a context-responsive site planning and design. Other major offsite design influences may include local and regional infrastructure. Prevalent building styles may be reflected or echoed in new buildings and site design. An offsite landmark could also influence the siting or the positioning of a new building to give the building's occupants a prominent and unobstructed view of the nearby landmark. And microclimates can vary dramatically over short distances in urban environments. And so buildings, for example, can enclose outdoor areas and shelter these spaces from wind. In cooler climates, these pockets of calm air, especially if they receive direct sunlight, can have much milder microclimates than nearby wind or shaded locations. So by introducing new structures, you may be creating a microclimate within your site by redirecting wind and manipulating the air temperature within the site. So if you can do that, then these microclimatic regions can provide opportunities to create outdoor open spaces, make them as comfortable as you can. Conversely, relatively harsh and uncomfortable microclimates, they also exist in urban areas. For example, if you have tall buildings, a group of tall buildings, they can channel winds. Generally, if there's a concrete surface, asphalt, a hard surface, and towers and towering buildings nearby, then you'll have sort of a wind tunnel that is it becomes a very turbulent street, and that's not very desirable for outdoor dining, for example. And also, a lack of exposure to sunshine can make these outdoor spaces substantially cooler than nearby locations with greater exposure to the sun and protection from the wind. So the site analysis generally help designers understand the site's existing and potentially future microclimates. If you need to transform your landscape, you'd have to consider the interplay of many social, economic, and of course technological factors. Land use changes have been influenced by the rise of the global economy and by public policies affecting various activities from transportation and economic development to perhaps even the seemingly insignificant school siting or situating a school. Construction methods and materials also have become more internationally standardized, including Indonesia. I think there are more. I think we see nowadays we see a more uniform selection of building materials here and there. For example, if you're talking about the in architecture, we know of the international style, where the international architecture style usually involves a combination of steel, concrete, and glass. So, anyways, a lot of things are becoming more and more internationally standardized, and urban areas are these very complex social, economical, and ecological environments. And in this context, site analysis must examine more than just physiographic conditions, as demonstrated in this slide. Contextual analysis can also entail multiple lines of inquiry, which includes identifying neighborhood and community spaces and determining what activities and symbolic values that are associated with those spaces. Analysis may also examine how and why people use or avoid outdoor spaces. Post-occupancy elevation of, post-occupancy evaluations of outdoor spaces are particularly useful in designing urban sites. Spatial and temporal qualities of places are particularly relevant to urban infill and redevelopment projects. What you see here on this slide is a sample, or is an example of the sort of the sort of site analysis that you can conduct. Other than just overlaying, or maybe after you have overlaid multiple maps and attribute tables. If you're using GIS, then maps and attribute tables, you overlay them and you find out where which places are more suitable than others for development. Then you can continue your site analysis into further detail by identifying or indicating where main axes for development are, where potential views may be, and so on and such. Now, there is a thing or a phenomenon called placelessness, and to combat this thing called placelessness, I can't quite find the right words to describe what placelessness is. Perhaps it has something to do with the quality of a space, but let's just take the word placelessness and keep that for the time being. So to combat placelessness, careful attention must be given to create meaningful open spaces, to their spatial organization, and to their connectivity. And also the furnishings. Pedestrian circulation within and surrounding the site need to be analyzed to identify opportunities for creating entrance plazas and other pedestrian amenities. And this analysis should also look for problems mentioned here, lack of walkway connectivity, insufficient walkway capacity, um, potential conflicts among motor vehicles or conflicts between motor vehicles, bicycles, and pedestrians. Um, Ideally, if you can separate these three, then by all means, separate these three. Usually, you can still it is easier to put bicycles and pedestrians together, but if you put motor vehicles into the mix, um, then it's a whole different story. There's a potential for greater conflict there. Another problem would be lack of street trees and other plantings for to create shades and to create quality open spaces. There may be insufficient outdoor lighting. There may also be excessive outdoor lighting. Uh, Nobody likes too much floodlights unless you're creating a sports stadium. Then you, by all means, hit it with all the light you can. But most of the times, I think as long as you can provide sufficient outdoor lighting for to ensure night visibility, then it's fine. And the last problem we need to look out for is the lack of site furniture. If you happen to be if you happen to be developing an urban site, then street furniture or site furniture such as outdoor seating, outdoor tables, and other site furniture such as sculptures, they will add value. To a place, but if there aren't any furniture whatsoever, then that place would tend to have a would have a low quality value to it, and thus becoming placeless. Um, So, for example, a comprehensive neighborhood revitalization program would view these problems as potential opportunities to improve the neighborhood's livability and sense of place. Um, urban planners, uh, urban planners that you will someday become, oftentimes don't have a blank canvas to work with. Um, and if you happen to be involved in a revitalization or a redesign of a street corridor, then look for these problems, and these problems can become potential opportunities to improve that neighborhood. So, coming back, the site's boundaries or interface with adjoining properties and transportation infrastructure is a particularly important site planning concern. And the periphery or edge of the site, they do take a great or much greater importance when the site is small or linear in shape. Excuse me. Now, potential conflicts can exist between on-site and off-site activities, and these must be addressed during the analysis and conceptual design phases, as demonstrated here. Um, this particular corridor is divided into several segments, and each each segment then is or each segment is planned or in a way that that they interact with one another. So the arrows signify coordinated planning efforts, Perhaps especially so between or especially so in these boundary interfaces. They may introduce something that or they may place a greater focus on these existing on these segment boundaries, so that the transition from one segment to another may feel seamless, may feel continuous. Sorry. Now, off-site conditions can include nuisances such as a busy highway that can have an impact on the site with traffic noise, unpleasant odors, and potential safety risks. And when these conflicts do exist, program elements can be arranged to mitigate them. Land users or users that are less sensitive to these nuisances can be situated closer to these nuisances, than other more sensitive users. In either case, screening and buffering may be needed, but the selection of screening materials, which can include walls, fences, berms, and even vegetation, can occur a bit later in the site in the design development process. A site analysis focuses on more than just site constraints. And although this alone is enough to justify the effort, I think yeah, you need to go beyond. You need to go beyond constraints. You need to also identify the opportunities. So, amenities on-site and off-site may have significant social, economical, ecological, or aesthetic value, and these can include tree specimens or scenic views to natural features like water bodies or landforms, landmark buildings, and other major cultural features. Amenities may also include a unique rock outcrops or and historic or culturally significant buildings and structures. These physical assets, if integrated within a redevelopment plan, they can maintain a site's sense of place and thus enhancing the experience for future site users. Protecting natural and cultural amenities can also increase the property's value, make it a more desirable place to live. Site opportunities include locations that are potentially usable for one or more project objectives, whether they entail real estate development, environmental conservation or restoration, or a combination of these purposes. Together, the site's constraints and opportunities delimit the area of the site that can accommodate the project program. It's like putting together a jigsaw puzzle. The design solutions that fit the site oftentimes they elegantly capitalize on the site's natural and cultural attributes, creating a unique sense of place. A site's biophysical and cultural contexts generally reflect local, community, and regional influences. So it is handy. It is very handy if you can sort of indicate on your map. You can the opportunities and the cons, the pros and cons throughout the map. to give you a much better or a clearer picture of a clearer description of your site. Another element or another attribute or property to think about is identity. Identity can be shaped by contemporary references to earlier design styles, to earlier construction methods, or the kind of materials that they use. And these references create linkages to a site's cultural and history and environmental character. A contextual approach to site planning and design is a sort of land use ethic that seeks to create meaningful places that are also good neighbors with other sites surrounding them. Buildings that are constructed, buildings are constructed and sites are developed in ways that are sensitively adapted to both the historical and the contemporary contexts. And natural as well as built features give communities and neighborhoods unique identities. Neighborhood character is a product of the quality, of the accessibility and convenience of a place. And character, identity or character, is derived from the neighborhood's location within a larger community. Its mix and arrangement of land uses and the scale of its buildings and streets and open spaces. One of the important objectives of site analysis is to discover these special and interesting and valuable features or properties on your site and near the site. And these assets can range from unique natural areas to culturally significant local places to significantly, it's unique to someone unfamiliar with the neighborhood or community. And these valuable assets can be overlooked sometimes. Neighborhood character analysis, or if you want to assess the identity of a neighborhood or assess the identity of your site, you can try assessing the following elements. If there are any, have a look at the homes and streets in the site and off the site. I know that for the purpose of this unit's assignment, the site, your site will be considered as an empty site, but the surrounding neighborhoods isn't considered as an empty. They're not considered as empty sites. So have a look at the homes and streets there. Are there any community streets, and how are the community streets arranged and planned? Are there any neighborhood niches? Maybe pockets of green open spaces that are pleasant to visit. And are there any anchoring institutions, such as are there any significant structures there? Maybe an administrative function of an administrative building, a religious building perhaps, and so on. You may assess other elements as you go along in your site inventory and analysis. A bit of suggestion when you're assessing a site's character or identity, you may want to build a comprehensive photographic record of these character defining elements, and you can arrange them in an image board of some sort to help you sort of identify and help you design or orient your site towards um, these elements. Now this image board can serve as a reference during the design phases, and it can also serve as supporting documentation during the permit and approval process, if you need to get permits and such. Um, Other off-site design influences may include prominent landmarks, iconic buildings, and other spaces that may link these buildings, and an analysis of a neighborhood's architectural context. Also, you might want to document the styles and properties or characteristic details of the neighborhood, um, if there are such unique architectural features in the neighborhood. You may want to just document them to give you an idea of, this is how the site development should look like. Religious buildings, if you have any near the site, such as a church, cathedral, mosque, or any other institutions such as schools, or maybe a well-designed library, could also influence the siting, the situating of and the design of the buildings of new buildings nearby. Now, moving on to land use suitability analysis. Environmental conditions should principally inform land use planning decisions. Suitability analysis, in a nutshell, is the process of determining the fitness or the appropriateness of a given tract of land for a specified use. Suitability analysis is spatially explicit and very, very program dependent. And because land development can create significant off-site impacts that impose economic and social costs on others, so context-sensitive site planning seek to minimize these detrimental impacts or externalities. Site suitability is a function of the site's intended uses. Consider a partially wooded and hilly site along a small stream. Several attributes could be mapped, but not all of these attributes will be relevant to the program under consideration. The site attributes most relevant to a proposed nature conservancy, for example, would differ greatly from the site attributes most relevant to a proposed multifamily housing development. The analysis for nature conservancy project would place a higher priority on identifying the site's plant communities and wildlife habitats, from dry upland forests to lowland marshes and bogs. In contrast, the analysis for a housing project would place a high priority on identifying areas without significant building constraints, which include identifying steep slopes, shallow bedrocks, and shallow water table. And on that note, for your site planning assignment, you can, if you want, build some sort of a conservation and education area. If you do decide to build a conservation area, that does not mean that you can leave the site bare, leave the site as is. You may think that I'm gonna let's just plan a conservation forest and leave it at that. No, that's cheating. But A conservation area may also include walking trails. You can map walking trails, potential walking trails, and uh, accessibility options or accessibility networks for potential researchers who may conduct scientific observations in your site. I think I'll give you. I think I should give you guys an example of natural conservation development. But that option is on the table, and I think throughout my site planning unit teaching career, um, most of the times the students uh, decide to build something physical, um, and develop a site extensively. But conservation development is on the table if you decide to go in that direction for your assignment. And speaking of conservation, I would suggest in your future professional practice to avoid brute force engineering at all costs. So rather than using brute force engineering to overcome the intrinsic difficulties that some sites pose for development, if you have unsuitable locations, leave it undeveloped. If you can refrain and if you refrain from developing in unique natural areas, if your decision to refrain from developing in unique natural areas can be justified from an ecological and ethical perspective, and oftentimes it can also be supported from an economic perspective. Protecting and integrating this sort of this green infrastructure into the built environment can, if you do it well, it can increase community livability and property values while also reducing public expenditures for big pipe stormwater management, like the ones pictured here. So leave it bare, leave it natural. And what I mean by brute force engineering is that if you find, for example, a water runoff area, and you want to divert that runoff area in some ways, if you can avoid diverting it, avoid it, so that you don't disturb the site's natural features and natural processes as much. So, coming back to the land development and design. For example, residential subdivision design, or any subdivision or any site development involves much more than the efficient layout of buildings, lots, and streets and utilities. Typically, the most profitable and the most aesthetically pleasing design or plan is the one that takes advantage of the natural features and processes on site and off site, and make these features the neighborhood or the development focal points. Developing with nature is also fiscally prudent. It is a fiscally prudent approach for the municipalities in which the development occurs. Development that respects inherent environmental constraints, especially natural hazards, helps to protect public health, public safety, and public welfare, of course. Um, this sort of development paradigm also kind of celebrate each site's unique sense of place. It's really easy for us to consider ourselves we're engineers. Let's manipulate let's manipulate nature and nature's features through brute force engineering by introducing artificial or artificial landscapes and artificial infrastructure. But you see, the problem with these brute force with brute force engineering is this: um, if you take storm drains, for example, where do these storm drains run off to? Um, they either run off or divert water flow to the nearest water body, or they channel water or streams into the next big infrastructure. For example, a city's drain main drainage network, for example. Um, a simple example, or a simple illustration of the differences between these artificial engineer between these artificial infrastructure and the natural processes is that when water flows through these hard surfaces, they generally flow a lot faster than they would if they were to be left flowing on the natural landscape features. And when water flows on these natural features, they're slower, and it gives time. It gives time for the natural landscape to sort of absorb and recharge its natural aquifers and perhaps groundwater supplies. Whereas if you introduce these artificial infrastructures, water will just flow, and not a lot of it goes back into the groundwater. Not a lot of it goes back into contributing, I don't know, nutrients for the vegetation above it, and the like. So if you can, if you can uh, harmonize with natural features, then by all means harmonize with that. Work with the natural features, um, and try and avoid brute this sort of brute force engineering. Try to avoid these pipelines at all costs if you can, preferably. Um, Not just for the purpose of this assignment, but also in your future professional practice. Um, on relatively large sites, especially where built elements will cover a small fraction of the land parcel's surface area, suitability analysis is an important step in the land planning process. Typically, this means assessing the site's suitability for development, which involves the construction of roads and buildings. In rural areas without municipal services, then development suitability may also depend on the soil's capacity to accommodate on-site wastewater treatment systems, or support maybe special agricultural uses such as orchards and vineyards. Sites that are most suitable for agricultural use usually require fewer management inputs. Locations with prime soils, for example, require comparatively less irrigation, less fertilizers, and less pesticides, and less efforts and expenses to devote to erosion control. Land use suitability involves three steps. Three steps mentioned here: identify, inventory, and identify too. So identify the suitability criteria for each land use. I know you're thinking, land use, we're going to build a theme park. Yes, but within the theme park itself, for example, you have different land uses. On this plot, this segment of the theme park is for roller coasters. This segment is for indoor roller coasters. This other segment is for so on and such. So different land uses there. So different. They usually have very different criteria. And inventory, of course, conduct an inventory, create an inventory and map relevant site attribute data, and then finally identify and map locations with attribute values that meet suitability criteria. So you kind of mix and match between the data that you have in your inventory and the suitability criteria for each land use. Now, before beginning a suitability analysis, both the availability and reliability of the required data should be considered. For example, do the data exist at the needed scale, and can they be affordably acquired? Are the data current, and do they pertain to the suitability criteria for the proposed uses? A suitability analysis may also assess several cultural and biophysical attributes. If you conduct your suitability analysis using a mapping software, GIS, which I presume you will, the attribute maps in digital form and then suitability maps can be easily generated for each of the proposed land use. These maps can be combined to create on a single map a synopsis or a synoptic suitability analysis for the proposed project. I used to I think the first time I conducted a land use suitability analysis was with using baking paper. We have a base map and a layer of baking paper that sort of a layer of baking paper with the choropleth with a choropleth map that shows the contours and the topographic features of the site, and then another layer of baking paper, to show where existing utilities are, and another layer of baking paper to show watersheds and water flows and all sorts of things. So we ended up with several base maps and several baking papers layered on top of those base maps, because that's how I did it with my friends 20 odd years ago. It's a long time ago, manually. But now I think you don't have to do that, because you will be using mapping softwares. That just shows how easy technology has made our lives today. Thank God for that. No more baking paper. So a GIS database consists not only of maps, of course, but also data tables that are linked to the coordinates or points and lines and polygons on the maps. I'm not the world's #1 expert on GIS database and GIS analysis, so I'm just going to give you an overview of what I understand of the system. And so the location and attribute information for each map is then, for each map unit is then stored as um, like a table of data or tabular data. And the analysis of an individual attribute layer involves partitioning these spatial distribution of these attribute values. And so the primary objective of your site analysis is to find locations that are either greater than a specified minimum or less than a specified maximum, or within a specified range, some sort, I think, range of values. I don't know, but you're doing locational analysis. You should be a lot more proficient. You should be a lot more proficient in this than I am. These conditions create suitable or unsuitable places for one or more components of the proposed program. A map showing a site's range of slope percentages, for example, 0 to 5% or 5 to 10% is an example of spatial partitioning. This slope map is useful because some land uses are better suited for gentle slopes and others are better suited for steeper slopes. In gently rolling to nearly level terrain, existing slopes may have little effect on land planning and site design decisions. In steeper terrain, however, maybe elevation, slope, and aspect will influence the site's hydrology, visual quality, and plant and animal distributions. Spatial buffering or proximity analysis helps you identify locations within a specified distance of one or more reference features. The resulting areas are either buffers or building setbacks or development setbacks. And the primary difference between a buffer and a setback is the direction of this spatial feature. It's usually either outward or inward from the reference feature. Buffers are generally buffers have a generally more outward direction than outward from the reference feature. So, for example, this is a property line, so the buffer would generally move outwards, but a setback would move inwards from the property line or from any reference feature. Buffer analysis is used to identify locations that require protection from development or locations that pose significant risk to human life and property, such as these features. So if you have natural resources or cultural resources or natural hazards within or around your site, then you may need to protect them, or you may need to buffer them. Buffer analysis can also identify potential components of a green infrastructure system. So maintaining an adequate plant cover within riparian areas and other buffer zones can significantly limit erosion. It can also limit sedimentation and pollution of an aquatic ecosystem by filtering stormwater surface runoffs. Riparian buffers, for example, can also protect important terrestrial habitats and climate adaptive migration corridors. Now, although multiple spatial analyses are possible with a digital GIS, a small number of analytical functions are most useful for site planning purposes sometimes. A site suitability analysis typically involves overlaying two or more attribute layers as demonstrated by the figure on display. The intersection and the union analysis are two most common useful algebraic functions performed on attribute layers. So you can either unite or you can intersect different layers to give you the desired results, such as this. A little word of caution. Although GIS is a powerful tool for spatially analyzing a site's physical, biological, and cultural attributes, it is easy for a GIS. The GIS also has this capacity to easily compare between apples and oranges, or apples and oranges, so to say. And these comparisons can lead to erroneous or erroneous conclusions. They can lead to misleading conclusions. You need to compare apples to apples or oranges to oranges. So how to avoid these apples and oranges situation? Usually you would use weighting schemes to assign priority values to key site attributes. And although it is mathematically possible to weigh or to assign weights to each attribute and arrive at an algebraic sum, the significance of these values may also be questionable. So it is a powerful tool. It is an intelligent tool, but it's only as useful and it's only as powerful as intelligence as the operator make it so. Suitability for a given land use can also vary substantially with regional differences in climatic conditions. For example, maximum feasible slope gradients for housing development will vary with soil and geologic conditions and climate. Locations with sub-freezing temperatures, for example, are, I think I've mentioned this before, but they're more limiting because of the dangers that icy conditions can create for pedestrians and vehicles. So steep gradients would be very impractical in a city with snowstorms and freezing winter temperatures. But not only that, steep street gradients can also be very, very dangerous in places like ours, where we have intense torrential rain every now and then. It would be as slippery and as dangerous as icy winter temperatures, for example. So yeah, typically, ideally, you would avoid development in gradients that are more than 15%. But as I demonstrated previously, there are some streets. There are some streets or some places where development takes place despite very extreme gradients. So to wrap it all up, land development can result both in reducing, can result in both during and after construction. It can result in externalities that degrade the environment and impose substantial economic and social costs on others. Informed by careful site and contextual analysis, however, new development can be designed to minimize these adverse impacts on the environment and on the community. So, development shaping site constraints can be shown diagrammatically on both the site analysis and concept plans. And each site presents a unique combination of physical, biological, and cultural conditions that preclude a one-size-fits-all approach to its planning and design. Each site is unique. There's no one-size-fits-all in here. Development suitability depends on the site's opportunities and constraints for specific land use programs under consideration. And favorable site locations have attributes that are either essential for the program uses or enable access to areas well suited for these uses. Unfavorable locations prevent these uses from occurring or increase the difficulty or increase the cost of situating or planning uses there. And that is all I have for the site planning, for the site analysis session today. If you, some of you may have questions or comments, then if you do, please fire away and unmute yourself. No, well, I hope that this session sort of complements what you are learning in locational analysis, in locational and spatial analysis, in the locational and analysis unit. And if you don't have any further questions or comments, may I remind you that for the purpose of the site planning group assignment, you're more than welcome to consult. If you have a site in mind, if you come up with a site in mind, you're more than welcome to consult with me or Pak Dewa to see whether the site that you're proposing is suitable for the assignment or not. Other than that, no, I don't think I have any further information for you guys at this point in time. Thank you all for coming to this morning session, and I look forward to seeing you all again next week. Have yourselves a great day today, and Assalamualaikum warahmatullahi wabarakatuh.